everyone, welcome, and I am absolutely thrilled to guide you through today's explainer. We're going to be digging into some truly fascinating science today. But before we jump right in, I want to give a massive shout out to our sponsor, AirKaroli. If you want to stay ahead of the curve on global news and geopolitics, the absolute best way to do that is to check out the AirKaroli YouTube channel, follow the AirKaroli Facebook page, and visit the AirKaroli website. They do incredible work, and we're so proud to have them bring you this deep dive.
All right, so picture this. We live in a rapidly warming world, right? We hear about it all the time. But right now, there is this chilling mystery unfolding deep in the North Atlantic. A massive, freezing patch of water is just expanding. It completely defies everything we think we know about rising global temperatures. And honestly, it points to a much larger, potentially catastrophic shift in how our entire planet operates. What we are really looking at here is the potential collapse of planetary currents.
Here is the roadmap for our investigation today. First, we'll unpack the cold blob mystery. Then, we'll look at the Great Ocean Conveyor. Third, enter the Super El Niño. 4, extreme global weather impacts. And finally, number 5, tracking ocean tipping points.
Okay, let's dive into this. Section 1, the cold blob mystery.
So, scientists have actually dubbed our primary suspect the cold blob. And, well, it is exactly what it sounds like. It's a massive, expanding patch of freezing water situated right between Greenland and the UK. Now, you might be wondering, why on earth is there a freezing patch in an ocean that is otherwise absorbing record amounts of heat? Good question. It's actually our very first major clue that the oceans aren't just absorbing heat anymore, they're actively rewriting global weather patterns. This blob is a huge red flag, suggesting that a critical climate current is starting to collapse. And the crazy thing is, we're already seeing the effects of these shifting patterns on land. To put that into perspective, look at this number, 20%. According to recent research in Communications, Earth and Environment, European winter snow cover for December and January has dropped by a staggering 20% since the start of the industrial era. That's huge. This rapid shrinkage of those classic northern winters is a direct reflection of the changing thermal dynamics happening right now in our oceans.
Which brings us to Section 2, the Great Ocean Conveyor.
To really grasp why this freezing anomaly is just sitting there in the Atlantic, we have to look beneath the surface at the ocean's intricate plumbing system. The key player here is something called the AMOC. That stands for the Atlantic Meridional Overturning Circulation. Think of the AMOC like a giant planetary conveyor belt. It carries all this warm, salty water from the tropics all the way up north. When that water gets to the North Atlantic, it cools down, gets heavier, and sinks. And that sinking motion pulls more warm water up right behind it. It's basically a brilliant global heat regulator, but that conveyor belt is currently under severe threat. Let's move to and see how this builds step by step, because it's like a giant domino effect. First, as global temperatures rise, the Greenland ice sheets melt. Second, this dumps a massive layer of fresh water into the ocean. Third, because fresh water is way less dense than salt water, the ocean's salt levels become critically diluted, meaning the water doesn't get heavy enough to sink anymore. And fourth, without that sinking action, the entire warm water conveyor belt just slows down. The warm water doesn't reach the north, and boom, you get a cold blob. And the data gets even more alarming. Recent studies published in environmental research letters show that when you factor in the permafrost carbon-climate feedback loop, which is basically just thawing frozen ground releasing even more greenhouse gases, it increases the chance of exceeding tipping elements like the AMOC by up to 50%. 50%. We're literally dealing with highly probable collapse scenarios if these feedback loops just keep going. So the Atlantic is clearly showing some severe signs of stress, but our planetary climate is deeply interconnected. So what happens when the Pacific Ocean decides to join in on this disruption? Before we pivot our narrative across the globe over to the Pacific, I want to pause exactly halfway through our explainer here to say a huge thank you to our sponsor. If you're enjoying this investigation, please make sure you subscribe to the AirKaroli YouTube channel, give a follow to the AirKaroli Facebook page, and definitely visit the AirKaroli website at airkaroli.com. Supporting them is what allows us to keep bringing you these deep dives into our world's most critical systems. All right, let's keep going. Section 3, enter the Super El Niño. We are talking about the arrival of a super El Niño. Now, a regular El Niño is a natural warming of the Pacific, but a super El Niño, that's a powerful, rare climate event that shifts massive amounts of heat straight into the atmosphere. When you combine that intense warming in the Pacific with the freezing cold blob in the Atlantic, you get a highly dangerous double anomaly. The planet's two largest oceans are essentially fighting each other, and this is actively disrupting the global jet streams that dictate all of our weather.
Section 4, Extreme Global Weather Impacts.
Because this isn't just a theory on a whiteboard, it's happening right now. And this brilliantly illustrates what we are talking about. We are seeing a severe dichotomy of disaster happening simultaneously across the Americas. On one hand, you have regions like California experiencing heavy torrential rainfall and crazy flooding. But then, on the exact same continent, you look down at South America and you see dry, parched, and cracking farmland just baking under a harsh sun. These disrupted jet streams are locking extreme weather patterns firmly into place. And the human impacts cascade so quickly from there. As these jet streams are disrupted, we're seeing severe insurance crises emerging in vulnerable floodplains. The financial models simply cannot keep up with the frequency of these unprecedented storms. And even more critically, these extreme shifts from torrential rain to severe drought are posing massive, massive threats to our global food supplies. Section 5. Tracking ocean tipping points. So, with these massive planetary shifts underway, how are we actually responding? Well, on the political front, the reality is complicated. The June 2026 UN climate talks in Bonn ended in what was widely reported as a gridlock. According to the sources, developing countries and richer nations clashed pretty hard over balancing the urgent need for climate adaptation finance with the desire to push forward on strict emissions cuts. A lot of the negotiation ended up just totally stalled under procedural rules, which pushes those really difficult decisions down the road to future summits. Now, what's really interesting about this slide is that while politics might stall, the action happening on the scientific front is incredible. Marine scientists are actively out there deploying advanced deep-sea monitoring systems to track salt and temperature levels in real time. This data is absolutely crucial. Alongside this, experts are heavily emphasizing that managing this crisis requires global cooperation on marine preservation and a rapid, large-scale shift to secure, clean energy networks to halt the warming before these tipping points tip completely over. We really have to remember this crucial fact. Oceans absorb 30% of our carbon dioxide emissions and the vast majority of the excess heat those emissions generate. The oceans are, without a doubt, our greatest ally against climate change. But the cold blob and the AMOC slowdown, those are clear signals that our ally is becoming exhausted. Protecting the ocean is paramount before these immense planetary systems break down entirely. Which leaves us with one chilling, yet incredibly important question. Are we prepared for the rapid shift in global climates? The oceans are sending us their signals loud and clear, and the next few years of scientific monitoring and global cooperation are absolutely going to define our future. I want to sincerely thank you all for joining me for this deep dive today. To stay ahead of the curve on global shifts in complex topics exactly like this one, make sure you stay informed with AirKaroli. Head over right now and subscribe to the AirKaroli YouTube channel, follow the AirKaroli Facebook page, and definitely dive into their amazing resources at the AirKaroli website. They make explainers like this possible for all of us. Until next time, keep learning, keep asking questions, and stay curious.